Shah. I'm the founder and CEO of Amaranth Medical Analytics. So the motivation behind hosting this challenge was that typically the challenges regarding digital pathology are geared towards data scientists, and it requires coding skills. Also, you need to have the computing infrastructure to be able to train your models and all. What we wanted to do was let pathologists build their own AI. So all they need is the domain expertise, and um, no coding is required. We also wanted to get user feedback in terms of the platform we have built, how useful it is, um, how can we improve it, and so on. So I'll just start with how you can register for the challenge. Most of you have gone through this process, but first you register on the platform. Once you've done that, you will be able to go to the challenge page. And if you are already a part of a team, then you will be able to select that. Otherwise, you create a new team and you join the challenge. And it will take uh, a couple of minutes for the data and all to be set up. Once you do that, you'll be taken to the home page, where you will be able to go to your challenge page and start exploring the data. The next step you may want to do is build a team. Um, so you have that option from the projects page. You go to the add members page, and here is where you will add a member. You would click on that button, enter the email address, and then there are different roles. Typically, you would want them to have the admin role so they can make changes to the annotations. And you invite them. A lot of the times, the mail can go to the spam folder. So you may want to check with them if they received the mail, and check their spam folder for that. So you can add members as required. Again, there is no restriction in terms of the number of members. um, and it can be even a team of one. So the main objective of this challenge is to build an AI model that automatically identifies all types of blood vessels in whole slide images so that we can fully quantify and study the distribution of these vessels. In terms of the types of blood vessels, it could be any arteries, veins, capillaries, as well as specialized vessels and structures. Um, I have tried to annotate majority of them, but it can be very tricky to annotate the sinusoidal capillaries, so I've not annotated that. But if you're able to, then you can do that as well. The next step would be you would review all the annotations that we have made. There will be mistakes, so you can make corrections. You can add more annotations as needed. And whatever annotations you make will be visible to your team members. Um, we've also provided results of Bayes model for doing blood vessel detection using the data that we've already provided. So you'll be able to see the output of these models. And again, you can review the areas, and wherever there are mistakes, you will make corrections. Then the next step would be to upload your own images, which could either be from your institution or you can get it from public domain. There are many resources for that, and we can help you with if you're looking for specific images. And we support most of the WSI formats. Once you upload the image, you can then run these Bayes models that we have provided and look at the results. They would not be as great on these images as they are on the training set that we have already provided. So wherever there are mistakes, problems, you can select those areas to create more annotations. And once you do that, you will start training your own model with the challenge data that's already provided plus your own data. This you can start doing this next week itself. Um, once you are happy with your model, it can be submitted uh, for the final evaluation. And we will do that for some of the images where we have ground truth uh, obtained from the spatial transcriptomic data. And then finally, we'll have the winners and the prizes and all. So today's webinar focuses on how to view the annotations, how to make corrections, how to upload your image and run your base models. So the data set and the annotation table is available on the AI challenge page, and on the viewer, you can view it on these two layers, train data and train data editable. So uh, this is the challenge page. And in the additional information, you'll see dataset and annotations. That's where we have all the image names, the case ID, the source of the data, if there are any pathology notes available, diagnosis, if available, and site of resection, as well as the number of annotations that are originally provided. So you click on the go to platform, and this will take you to the challenge project. Uh, these are your different teams. If you have multiple teams, then you can switch teams from here. Uh, you may want to participate only from one team. And uh, there you will have any notifications, new things that are upcoming in the context of the challenge. Your challenge project is always accessible from the home page. Once you click on that, you will see the data set with all the images. Click on the image, and that's where you start seeing all the information. There are layers which you are created under my layers. There is challenge layers, and then one shared layer. You can view the information about the image from here as well. And so train data layer is something that you cannot edit. So it's always available to you in the original form. But the copy of it is the shared with me train data editable. It's the same as the train data, but now you can start adding and making corrections to the annotations. Um, so if you click on an annotation, you get the option to change the annotation type, delete it, change its boundaries. Now, there are different tools available on the layer. So there are different layer controls. One is the visibility. So you can switch on and off different layers. So this is now we are looking at the base model 1 output. So it has run inference on the whole image and identified all the blood vessels, or tried to identify all the blood vessels. It would make mistakes. So you can explore that through these layer controls. Next is the fill option. So you can color fill your annotations instead of just the boundaries. The other is the opacity option, where you can increase it. So you can make it fully opaque, and then you can reduce it to see the overlay on top of the image. You can also change the magnification of the lines to make them more visible if needed. The other three dot options, we'll not go through all, but the main important one is the summary, where you will get the table of how many blood vessels were found, the area covered by them, and then all the other calculations like um, percentage of counts, count per millimeter square, percentage area, and you can sort this as well as you can export all this data. You may not need this for this challenge, but uh, these features are available for any models that you build. In this case, you can see that it has identified mostly fat, stroma, blood vessel, and a little bit of glands. Everything else is just a little bit of noise. So once you have seen that, you can also look at the model details, the details of the model that was used to create this layer. You can edit the layer name. So this tells you how the training had happened, for how long the training was done. We will go over some of these things in more detail when we do the webinar about training specifically, but it shows you how the error is decreasing as you train further and further. And then for each class, how the error changes in the training data as well as in the validation data. You will also see a confusion matrix. So all the different annotation types, um, the actual annotations and what is predicted by the model. So in case of blood vessel, you can see that 92.8% is the accuracy. And then there are some errors. Some of the blood vessels are getting confused with stroma, so they are being missed. And then this gives other details of the model, that there were 43 images that were used for creating this model, number of pixels for each annotation type. This you can just look at the confusion matrix in pure absolute numbers or percentages. Mm. Again, more details on this in another session. Now we look at the second model. So the first model had blood vessels plus other annotations. The second model is just blood vessels, and everything else is clubbed into just um, one class. So that's the difference between the two models. Your final evaluation, you can choose to do whichever way you prefer, but your final evaluation is going to be only based on the accuracy of blood vessels. So this is the output of the second model. And same, you can view the summary of it. Both the model details can be visualized on these from this links. And now we'll just see how to upload an image and how to run inference and view the output of that. So from the dataset page, you will have this add image option where you choose a file and then you will upload it. it's very important that you enter the magnification information. It will try and automatically detect, but if it doesn't, then please specify what magnification it is. You can check that even in QU path, the magnification. If you are having any trouble with that, again, let us know and we can help with that. Without magnification, the models will not run correctly. So as it gets uploaded, you confirm the upload, and then you can take a look at your image. This was the one that we uploaded. So you can see that. Now you can, for this particular image, you will not see any of the challenge layers because no annotations were provided by us, and we've not run the model on it. So you will have to run the model, and you press the run model button. You choose the two of the base models to run, and it will create a job for you. So we are creating both, we are running both the models, and it's created these jobs, which are then visible from the jobs tab. And you will also see the notification that the job was created. But here, once the resources are available, it will run the model. Typically, these take anywhere between 2 to 4 minutes to run. And in the meanwhile, you can continue looking at other images, running it on other images as well. So after a couple of minutes, when you refresh, you'll be able to see the output of the result. So this one is the second model where we are only identifying blood vessels. So you can take a look that it has found something, but there are also mistakes. Boundaries are not very good. You can start making corrections in these areas. So again, you can take a look at what is the status of the second model that we were running. Yeah. Status of the job. Now you can see the second one has also run, and you can visualize the output of that. And again, you can individually make different annotations visible or invisible. And you can see for this model, the boundaries are slightly better than the previous one. You can see it has found some, missed some. Mm. Next, we will see how we can add more annotations for segmentation where we have more than 2 classes. So that's the base model one. You can edit the existing annotations, add more regions. So identify an area for annotation and create a rectangle. That would be the area you will fully annotate. So then you want to annotate the smaller area within that and then the smallest. So you go in the order of size typically. And you can use some magic annotation tools for quicker annotations. So an example is this image where we first look at the train data. So these are the annotations already provided. The nice way to cycle through all these annotation is to use this annotation cycler. What it will do is for the selected layer, it will go through each of the annotations. So you can uh, take a look and start making corrections as you cycle through all of the annotations. Now that you've taken a look at all of those, um, you can look at the output of the base model. Again, take a look at the summary. Mm, You can start exploring. Let's say in this area, you have some mistakes. You select this area. So the first thing you will want to do is go to your train data editable layer. You will sorry, select stroma, then a rectangle tool. Um, you will shift click and then make the rectangle. Once you do that, the idea will be to make correction first, actually import all the annotations from the base model layer. So you can right click and say import annotations from base model 1 output. This allows you to not have to make all the annotations from scratch. So now these are available on the train data layer. Now you can edit them. So you can delete some of the wrong ones. Now, if you want to make additional annotations, we have this rectangle type magic annotation tool where you would make a bounding box. And when you do this for the first time, it will take a little bit of time because it will download this model. Um, we've tested this well on Google Chrome, so please use that browser. And subsequent uh, annotations will be much faster. Again, you can edit uh, the boundaries of these annotations as well. Go to a different area. So let's say here we can see there are a lot of mistakes. So uh, you can again make the same thing. You can create a rectangular annotation. And you may just want to annotate from scratch, in which case you don't need to import any annotation. You can directly start creating the annotations. Just see a couple of examples. When you're using the magic annotation tool, you want to make sure your bounding box is tight enough. That will determine how well the boundaries are drawn. Whichever annotation type that you choose from the annotation panel is the one that will be drawn using the magic annotation tool. So let's say you're happy with this area, you can go on to next area or even next image. Um, just one more example of making the annotation without using the um, magic tool. You can directly use the polygon tool. So here is the polygon tool, and you can do that as well. If you make a mistake, you can just change the annotation type. So next is for base model tool. It's pretty much the same concept, except you just want to annotate blood vessels. Um, so here what you will do is you can create a new layer for this purpose, or you can make changes to the train data as well, where you will delete all annotations except for the blood vessels. So you can uncheck blood vessel and then say delete annotations. It will uh, delete everything else. And you still have to specify the rectangular area which uh, you're supposed to train the model on. So you may go ahead and make those. Then you can explore, choose the areas of uh, importance wherever there are mistakes, you can start making corrections. So so yeah, you go over the whole area and make mark everything here. So that's how you would do it for this. So let's say in this particular case, we can train only on one image also. So you would say train model, type in the model name, choose on which layer the annotations it should use from, So in your case, mostly it will be train data editable, or if you've created a new layer for training data, you can use that. We are using the segmentation, and there's only one model architecture for that. Again, all these advanced options we'll go over later, and more details about them is also available in user documentation, which also I will show briefly. You select all the annotations. Unless you want to avoid any, you can select all and then say train. That's all. Once you do that, your job will be set up, and you can check it in the jobs tab. You can see that it has created a job, and its data generation is starting. And once that's complete, it will go ahead with the training. So while it is training, you can actually check the performance of the model in real time. So the earlier thing that we had seen, this is being updated in real time. So you can see how the training is going. And we'll again explain these curves and all a little bit more in detail in the next session. But and while it is being, once the training has started, the model which is best so far will be available for you to try out. So you can create a job with that. And again, that job will be visible in the inference jobs, and it will get started whenever the resources are available. Um, and then once it is run, the model output will be available in my layers. Uh, and you can see how it has performed. Of course, this was just an example with just one image and very little training. It's been able to identify this on this specific image. Likelihood of this working on other images is very low because we just used one image to do the training. Now, similarly for multi-image, you will do this from the dataset page, and you will select as many images, typically all images, but if you want to choose a subset of images, you choose that, and then you say train model. Again, type in the model name, choose the architecture. And again, we'll go over the advanced options later. And yeah, you can select your layers. You can select multiple layers if your annotations are on different layers. And then just finish. Again, a job will be created, which will be visible on this jobs tab. If you go there in the training data, you will see that the job has been set up. It has not started yet. Then the other way of training this is right now we are doing the segmentation, but we can also consider blood vessel as an object and do detection approach. We haven't tried this really, so we are not sure how well this will work. But I just wanted to show how you would go about annotating if you wanted to take this approach. Uh, you'll create a new layer. Let's say we call it train object, and you can create this layer across all the images in your data set. So it will take few seconds to do this. Once you have that, you can start annotating. Again, we don't need to annotate from scratch. We can just select regions of interest. For object detection, you have to create ROIs. So your region of interest has to be marked, and then you can right click on those. So you can annotate from scratch or right click and import annotations from the base model. That way you don't have to make a lot of annotations. And because we are interested in just blood vessels, we will import only blood vessels. So, so it has all the data. Now you can see there are 727 blood vessels which have been made. Of course, if you also want to annotate all the small blood vessels that have been missed, you can go ahead and do that using the drawing tools all available here. So once you're happy with all the annotations, you would go ahead and again do the train model. Same thing, you type in the model name and the layer on which you want to train. And here you will, because you just want to use blood vessel, you will choose that. And the architecture is detection in this case. And again, these two options will go over. But for this particular task, Dino is the best one to use. And then we will train the model. Again, it will show up in the training jobs, and then you can monitor it here or from the platform page on the jobs tab. So these are the few different training options that will be available starting next week. And again, we'll describe more details about how exactly the evaluation will happen. But this is an example of an image from glioblastoma, where we have the spatial transcriptome data, and using the endothelial markers, we can identify all the endothelial cells. So we will calculate how many endothelial cells are within the blood vessels that were detected and outside, and how compact these boundaries are. So it will be a combination of that in to assess the models and rank them accordingly. So these are some of the resources to be aware of. Of course, this is the login page directly. If you're already logged in, then the platform you can access directly through this link. Challenge page will keep updating as we go forward. And then user documentation is something that I will just briefly show that, which you should use for any usage related issues. You can email us anytime for uh, related to questions, or we have WhatsApp groups, we have Slack channel, whatever you prefer. Just a note of caution to use Google Chrome. Now, just the documentation I wanted to show. You can access the documentation from this. Here is the documentation tab. So if you click on documentation, you will see how to get started, how to create an account, um, how to create a project, all of that, um, how to work with the viewer, what all different options are available, how do you work with the annotation panel, different annotation controls. We have, I think, the magic annotation, we will update these tools as well. Different viewer controls, what do they mean? And then the control panel, how to work with different layers, and especially how do you use different layers. And main thing you definitely want to go over is the annotation guidelines and specifically for the segmentation. So it tells you the main points to remember when you are making the annotations. And if you follow the detection route, then there are, again, guidelines for doing that. And uh, all the parameters are explained here as well. So, yes.